This is video 5 of looking at how to find binomial distribution values with your calculator. So we're going to look at another example, and I'm not going to take out the calculator and show you how to do them. I'm going to assume that you can take your calculator now that you've seen the example on the first page, but I'm just going to set these up for you. So this particular problem says that Alex has a 30% chance of correctly answering questions on a multiple choice test. And we're going to assume that that's the probability for every question. He has a 30% chance of answering them correctly. Let's suppose that there are 5 questions on the test, and we're going to let X be the number of questions that are answered correctly. So we're first going to just answer some basic questions about this, and then we're going to calculate some probabilities. So for part C through G, that's where we're going to be using the calculator. We're going to label the work with the correct standard probability notation, just like we did on the first page, either probability that X equals something, or is less than something, or greater than something. And then we're going to use the binom PDF or CDF on the calculator to evaluate them, and we're going to round them to 3 sig figs. So the first says, let's write the sample space for this random variable. So if there are 5 questions and X counts up how many questions are correct, then X could take on the values of 0, 1, 2, 3, 4, or 5, right? And on your homework, I'm going to ask you, just pay close attention to the directions. I'm going to ask you to write the sample space for your problem, and then also write the binomial distribution for your problem also. The book doesn't ask you to do that, but I'm going to ask you to do that because I think it's important for you to kind of have a picture of what the outcomes look like, and then also to have the binomial distribution set up so that you know what the values of n and p are when you're trying to put that into your calculator. So first of all, let's just confirm that this is a binomial distribution. So remember, the first thing we have to acknowledge is that there are 2 possible outcomes, success or failure. So either he gets the answer correct or he doesn't. The second thing is that there has to be a fixed number of trials, and that's n, and we know that n is 5. So remember, this is X follows a binomial distribution with n and p. So we're putting a 5 in here. And then there has to be a set probability of success, and that's going to be 0.3. So that goes in here. So we can kind of acknowledge that this is binomial. So that'll help us as we go through the rest of the problems. So the next one says, what's the probability that Alex gets exactly 4 questions correct? So if I want exactly 4 questions correct, I just want this one. And so for that one, let's write the correct notation for that. So this is going to be, we want the probability that X is equal to 4. And so we're going to use, I'm going to write this down here. IB does not expect you to write this notation, the calculator notation. They want this notation. But I'm going to write down here what you're going to put into your calculator. So it's going to be binom PDF. We have 5 trials, probability of success 0.3, and we want to find out what's the probability that X is equal to 4. So if you go to your calculator, and I've shown you how to do that, and put that in, you're going to get 0.02835. And the directions say to round it to 3 sig figs, which would be to these. So it's going to be 0.0284 will be the probability for that one. The next one, it says, what's the probability that Alex gets at most 2 questions correct? So if we're looking at most 2, again, the reason I want you to have the list here is so you can think through what that would mean. So at most 2 would mean we could have 0, we could have 1, we could have 2, but we couldn't have over that. We can't have 3, 4, or 5 because it says we can go up at most 2. So notice that what we're looking for here is just the probability that X will take on the values that are less than or equal to 2. So we're going to write, we want the probability that X is less than or equal to 2. And then remember that the way that you get that is we want to add up these 3 probabilities, and we do that with binom CDF. So we're going to look at 5 trials, 0.3 chance of success, and then we want 2 here. And that will automatically add up these 3 probabilities. It'll add up the probability that X is equal to 0, plus the probability that X is equal to 1, plus the probability that x is equal to 2 for us. So we don't have to do it. And again, I'll let you go to your calculator and do that. This is going to turn out to be 0.83692, or approximately 0.837. So I'm going to stop here, and I will do another video for the last three.